Okay, let's talk about this particular section. Now, this particular section is a little bit complicated. So the first thing that they bring up is your trigonometric inverses. Um, Now, the thing to know is that they are presented as trigonometric inverse functions. To be a function, you must have um, one input going to one output. Okay, so we know that sine, cosine, and tangent are functions. Okay, so we're going to go down here for a sec, and we're going to take a look at the sine function. Okay, so that's the sine function. We know it's a function for one input. There's only one output. Okay, but sine is not one-to-one. Okay, what that means is if you find the inverse of sine, just normally switching the x and y and solving for y, the sine inverse is not a function. So what we do is we take a piece of sine. Okay, we take a piece of its domain with the corresponding range, and we basically force that function to be one-to-one. So we only look at negative pi over 2 to pi over 2 as the domain. So if I only look at this part right here, okay, that means my range is negative 1 to 1. Okay, now to find an inverse, if you recall, you switch the x and the y. So if I do that, if I take this graph and switch the x and the y on it, I get a graph that looks like this. Okay, so if I look at the function y equals sine inverse of x, okay, its domain will be negative 1 to 1. Its range will be negative pi over 2 to positive pi over 2. Okay, so when you use an inverse function, okay, what you're doing is you're taking a ratio and telling me what angle goes with it. Okay, so there are many, many, many different reasons we would want a function to be one-to-one. Okay, one input for one output. Okay, we are going to talk about the difference between evaluating and solving an equation in a little while, but let's talk about cosine inverse and tangent inverse as well. Okay, so if I look at cosine, where's cosine? We have the same kind of issue. Cosine is a function. it has a domain of negative infinity to positive infinity and a range of negative 1 to 1. Okay? But the problem is with that, it's not a one-to-one function. Okay? So what we do is we selectively look at the domain of cosine and pretty much force it to be one-to-one, similar to sine. However, we use a different cut. Okay? So cosine is going to go from 0 to pi. Okay, if we just look at that, then our function is one-to-one. So again, finding our inverse and graphing. Okay, so now the domain of the inverse is negative 1 to positive 1, and the range of the inverse is 0 to pi. Again, cosine inverse of a ratio will give you an angle. Okay, we're going to do the same thing for tangent now. Okay. So this is y equals tangent. Now, this one's a little bit easier. Okay, tangent has asymptotes. So instead of looking at the entire thing, okay, what we do is we look at tangent. Its domain is negative pi over 2 to positive pi over 2, and its range is negative infinity, positive infinity. So when we do this, we're only going to look at this bit. Like that. Okay? Now, if we look at tangent over its entire domain before cutting it, then we can say x cannot equal multiples of pi over 2. Okay, so when we look at tangent inverse, okay, the domain becomes negative infinity to positive infinity, and the range becomes negative pi over 2 to positive pi over 2. Okay? Now what this means in the long term is sine inverse has angles in, oops, I should start over. Sine inverse has angles in quadrant 1 and 4. Tangent inverse has angles in quadrant 1 and 4. But notice that quadrant 4 angles are negative. Cosine inverse has, did you know has was spelled with an E? Angles in quadrant 1 and 2. Whoops. Okay? So for sine and tangent, you'll have positive and then negative angles, positive, negative angles like that, and then positive, positive angles for cosine. Okay. Now, it is very easy to get confused with the cosine and the cosine inverse. So with the next video, we're going to start super slow. Okay, we're going to do some simple ones and then hopefully build up to what you guys need to do for your homework. Okay?